So let's start our next section, 13.3, which is about partial derivatives. So the first thing I want to do is I want to recall how we defined derivatives back in Cal 1 for a function of a single variable. The formal definition is that the derivative is equal to this limit of this difference quotient. And so we can now start defining our partial derivatives of a function of two variables. So if we have a function of two variables, remember we write f of xy, but this will be equal to z. And so then we have two first partial derivatives. The first partial derivatives of f with respect to x and y are the functions f sub x and f sub y, defined as fx will be, it's a function of two variables, and it's defined to be the limit as delta x goes to 0, f of x plus delta xy minus f of xy over delta x, and fy will be similarly defined. It's the limit as delta y goes to 0 of f of x y plus delta y minus f of xy over delta x, provided the limits exist. So what I want us to do for just a second is look at these formulas here. So if I look at this first one for fx, if you look, y is staying the same. It's only x that's changing. So to find f sub x, what you're doing is you're going to consider y constant and differentiate with respect to x. And the same thing goes for fy. If I look up here, x is not changing. Oh, that should have been a delta y, sorry. Back here, this should have been delta y. So to find f sub y, you're going to consider x constant and differentiate with respect to y.